So this is how the linked list will appear and operate for us. In general, we will, of course, have our struct, and let me draw that struct out here real quick. So our struct here actually does not allocate any new memory. We don't see the new keyword anywhere here. That is going to appear later when we start doing some linked list operations. But for now, just know that even though we are saying this is a node, this is just the blueprint for it. We haven't actually created any yet. Now, eventually, we will, in our main program, we will create a node right here, a pointer to a node. Let's say we call it head, and we'll initially have head pointing to the null pointer because we don't have anything for it to point to. When it comes time to actually enter some data into the linked list, well, we can get that data from the user, and we'll eventually put it right there, but we will use the new keyword. So this is going to be a new node. And then now that we have that reference or a pointer to that new node, then we will just add the value to it. So whatever we had collected, we'll put in here. Let's say it's 5. And then, we'll tell the pointer here to just point to the null pointer for now. And then all we have to do to finish this operation is to make sure that the head pointer is no longer pointing here, but instead pointing to that node that we just created. So we'll then just repeat this process over and over. Let's create a new node here. Let's put some numbers in it. This one can point to the null pointer for now. And then we just have to do some housekeeping and tidy up the pointers. This pointer right here that was pointing to node containing the 5, that pointer now needs to just be rerouted. So it's pointing to this next newly created node. And that's essentially what's going to happen as we build this linked list. Now, basic operations for the linked list will be appending a node. And we can append a node either at the beginning of the linked list or at the end. And I'll show you code for both of that. We can insert a node somewhere. Let's say that our linked list has some values that are sorted. They are ordered descending. We can traverse that linked list and find just the right insertion point in order to keep that ordering intact. We can traverse a linked list. If we want to print the contents of a linked list, yep, we have to start at the beginning and just go node by node by node, visit each node, and there is our printout or reversal of the list, maybe to pull values. And we want to sum the values to perhaps create an average. Then the last thing that we need to learn is how to both delete a node, but then to delete or destroy the entire list. So we'll get into some techniques for that.